So we're going to go in and cover using Amazon.com's technologies for recommendation and forecasting in your applications. So I'm going to spare you guys the forecast overview. I think we're going to start at the next one. So I'm going to spare you guys the full stack overview. I think you've seen it. Probably see it again a couple more times this week. But just to talk about where we're focusing today is we're going to focus on these two services. There is actually a third service that is using the Amazon.com experience of the last 20 years. We don't have that in this session today, but that is the fraud detector. But very similar to what you're seeing with personalized and forecast, that's the idea behind Amazon Fraud Detector. So customers often want to do things like recommendation engines, complex forecasting, but they may not always have full data scientist teams running full-time, doing data prep, featurization, all of the things that need to be done, which is where we've taken our services, which include industry-leading algorithms and concepts, and implement them into easier-to-use API-driven services. So I'm going to talk about two of those today, and then show some demos. We have Chris is going to come up and do the forecast demo, and I will be doing a demo of Personalize, which is our recommendation engine service. So, time series forecasting. Time series forecasting is forecasting data points indexed in time order. It's the use of that to predict future values based on previously observed values. So this is the past, and then you can use that to predict what would be a future state of that item. So useful in many different areas: product demand, workforce demand, financial metrics, inventory planning, EC2 capacity needs. So if you need to forecast your AWS needs or spend in the future, you could use a demand forecasting model to find out what you'll need to handle each season. Traditional methods struggle with the real-world complexity. Seasonality. So just the time series order of data doesn't take into account things like holidays or weather, doesn't consider additional item metadata, so of the item, so defining characteristics. And by item, as you'll see in terminology, an item would be something that you're forecasting. It could be an actual physical item, or it could be a video title. It really is just a construct. Doesn't consider such factors as holidays and promotions, so you can miss things based on what upcoming, Black Friday, Cyber Monday. That to a forecasting model might just be a day in November, but as you know, you can expect a higher demand in that time frame. Also, can't handle time series with no history, so you can't forecast data that has no historical data. So Forecast, an API-driven automated forecasting platform that draws from all of our experience, improves accuracy over traditional forecasting methodologies, also comes with several deep learning-based methodologies, as well as some classical ones like ARIMA, ETS, and Profit, which came out of Facebook. So we'll show you how you would get building these in the console, and there's actually a couple SageMaker notebooks that help get you started. So this is not a workshop, so we're not going to actually go ahead and have you build, but I'm going to show you where the GitHub code is that you can get started, and we'll walk through a quick demo of that as well. So some of the benefits of Forecast is it learns relationships between multiple related time series. So it understands the complex interdependencies of the items in a catalog. And again, item could be whatever you define as an item, your inventory, your library, for instance. It incorporates external data, holidays, promotions, into the forecasting methodology. It generates forecasts for new items. So items that have no historical data, it can help to generate forecasts based on that. And it predicts spikes. So we'll go through how it goes about doing that. So the time series platform, it works with any type of time series data. You export it and put it into a CSV format, but it can work with time series data that comes out of a database, out of S3. It is important. It has to be time series data. The models are your models. So it is building and training a model, but it is building and training a model in your account, in your environment. It is not shared beyond your account. Allows you to visualize and override the forecasts, so you can see the forecasts in, again, a nice console, but also in applications. And you can export data to many external sources, Oracle SAP, for instance. This, in a nutshell, and you'll see this again when we get to personalize, is the work that Forecast is doing. So what it allows you to do is it takes historical data and your related data, which could be the weather information, it could be the promotions, could be holidays, could be specific dates. And this is all managed within the service. If you were using something like SageMaker, one of the main algorithms inside of Forecast is DeepAR+. In SageMaker, you can actually run DeepAR as an algorithm. So if you want to extract yourself from Forecast and just create a forecasting model, SageMaker is an option. However, these are the things you'll have to do within SageMaker. You'll have to load the data, inspect the data, featureize it, or identify the features. Again, you'd be using DeepAR, or you could actually run Prophet or any other model in SageMaker, but you would actually pick the notebook for the model or bring your own model. You would select the hyperparameters, you would train your model, you would optimize your model, and finally you would deploy an API. Forecast simplifies all that into a service. So you are extracted from or not necessarily directly hands-on with things like featurization. Being that we're working with time series data, we can identify the features automatically. So it can also train multiple different models and give you the results, so you can decide whether you want to use ARIMA, Prophet, or DeepAR. It's also worth noting the 8 models that are included currently are just the current state. As any service at AWS, we seek to implement new features, new services, new models. So the current state is DeepAR, DeepAR+, ARIMA, Prophet, and I'll list the other ones. As new models come out, as new research is done in forecasting, we will add new algorithms. So it will automatically select the best algorithm, but that's another benefit, is your data is loaded in one place, and it can now be trained and implemented in multiple different use cases. So if you built a Prophet algorithm or a Prophet model in SageMaker, and then you wanted to do the same thing in DeepAR, the data might not be in the right format. You'd have 2 different notebooks running off of S3. There's a lot of different ways you would have to move that data over. This allows you to train multiple ones, all from the same original set of supply inventory data or your additional data. So 3 types of data sets in Forecast, which is your historical time series data of items to forecast. So that is your the actual inventory. Related data such as the price, any additional information, related things like web hits, and then additional attributes of the item. So it could be metadata, that could be color, category, genre, brand. These are all things that when you build out a forecast recipe, as it's called, and the recipe is a combination of the algorithm, the training, the deployment environment, you would actually be able to bring in different item metadata as needed. So then you generate a model pretty quickly. So you set up your data pipeline. You can choose AutoML, or you can choose one of the pre-built algorithms. There's a cost implication here. If you use AutoML, it's going to train in all of the algorithms and give you the performance metrics and allow you to choose what is the best algorithm or recipe in Forecast. If you know what you're looking for, say you want a deep learning based forecast, you could just choose to run DeepAR, for instance. Or if you know you want ARIMA or autoregressive integrated moving average, you would just choose ARIMA. So That's a choice you get to make between AutoML or choosing the pre-built algorithms. Sometimes you could use AutoML just to find which one is the right one, and then zero in on that, and then iterate that one algorithm. You don't need to run AutoML every time. Once you run in multiple models, you will get the accuracy, the score, and the information to give you an idea of whether that's a relevant model. So you would compare the accuracy across your models and then deploy the model. So once you know the accuracy, it will create and host a scalable API for forecasting. So similar to what you see with SageMaker, however, this is built into the forecast workflow. And from there, you're just generating forecasts via an API. So comparatively to SageMaker, where you spend a lot of time in a Jupyter notebook, you could actually do all of this in the console. I like the Jupyter Notebook methodology, which we'll show you in just a second, because it gives you a lot of information on what you're doing with the data. It is closer to like full, true hands-on machine learning for getting involved in data prep, data processing, identifying the features, that type of thing. So we do have SageMaker notebooks, but they're really designed to just automate the building of the service. So talking about traditional time series models. So here are the 4 included traditional, and by that I mean linear non-deep learning based models. A lot of these are industry standard: ARIMA, exponential smoothing, non-parametric time series, and Profit, which, as I said, came out of Facebook, I believe. Very, very understood, very highly explainable. However, your data must match the structural assumptions, and it cannot identify patterns across multiple time series. Moving into the deep learning methodologies. So these are using different deep learning methodologies: DeepAR, SQF, MQRNN, mixed density RNN. So these are the ones that are included currently. Allows you to do group dependent seasonality and life cycle. It can behave in response to covariate inputs. It has weak structural assumptions, but it can be significantly more accurate than some of the traditional methods. Another key component with deep learning-based ones is it can support cold start forecasts for new items, and it can learn from rich metadata. So we'll go into, I wish we had enough time to cover it all in detail. Here is the AutoML methodology I talked about earlier. So here you have the different recipes that you might use. If you run AutoML, it will run all of these back to back at the same time and give you the predictor name and the performance of each of those. This is a great idea if you don't know what model you want to run, you just want a good forecast. AutoML is a great way to do that. We'll talk about some of the drawbacks when we get over to personalize, however. A public use case is Mercado Libre, which has been using forecast to do product demand, which again is a key use case, but one of the key things about forecast is it's designed to work just across time series. Does everyone anywhere have time series data that they would like to create forecasts based on? Is that an area of interest? So it's designed to work across multiple time series data. It's not specific to products. Obviously, Amazon.com has used this type of technology, such as DeepAR, to predict product demand, but AWS needs to predict EC2 capacity needs. There's a lot of different demand forecasting that needs to be done. This is designed to work across multiple different time series models or data. Moving on to personalize, I want to make sure we get hands-on with it, so I want to get through. Very similarly to what I talked about with forecast, personalize is done for real-time personalization and recommendation. This has a lot of different areas for where you might want to create recommendations, and personalization is the concept of tailoring a service to an individual user. Recommendation is the concept of giving a prediction to what someone might rate an item, for instance. Personalization and recommendation are different. What we're talking about today is personalized recommendations, which is the goal of most of the models inside of Personalize. So some of the use cases: targeted marketing campaigns, product recommendations, so discovering the relationship between customers and or products, search browsing customization, so re-ranking a set of results. So if you have a set of search results and you want to rank those search results, you can personalize the ranking of those search results. So if I search for something based on what I've clicked on in the past, the results might be different. And this becomes very interesting when you have really large catalogs of data. When I search for a movie on Prime Video, it can give those results based on my preferences for things like action or indie comedies, for instance. So let's go into how it works. So again, some of the benefits: increase engagement, product discovery. So finding serendipity in products is important. There's a lot of different ways to provide recommendation engines. It's been an evolving space for 20 plus years. Some of the older methodologies are things like content-based filtering, or there's collaborative filtering, content-based filtering. Content-based filtering is essentially saying, I will filter your personalized results based on what you tell me you like. So those could be inferred or explicitly stated. But a content-based system will give you nothing unique, because I said I like rock music, so I'm going to recommend rock music to you. Where we get into deep learning and more complex recommendation methodologies is you can then find serendipity of results by taking all of the different interactions other users had with the environment and creating recommendations based on that. So again, increase product discovery, increase conversion, and increase revenue. So let's go into how. So some of the challenges of recommendation engines. Custom models, they must accurately reflect business context and user behavior. Real time. This particularly hits me as a media specialist. Real-time recommendations. So if I'm browsing Amazon Video, Netflix, any streaming site, what I'm looking for at that point in time is very indicative of what I want to watch at that point in time. Especially if you have Roku devices or devices at home where multiple people use them, the context changes multiple times throughout the day. In the morning, your kids could be looking for something. In the evening, you could be looking for something. Same user, same device. The real-time needs is very important for a recommendation. Cold start. When you're a new user or you have new items, what do you recommend, or how do you recommend them? Popularity trap is another common problem, which is sometimes, especially when using things like matrix factorization, you have so many popular items that are clicked on by so many people, you can get into a rut where you're just suggesting the most popular items to the most people, regardless of if it's relevant to them. And then finally, once you get recommending, scaling that recommendation engine is important. If you're doing a rule-based recommendation engine, you need to understand your content. This is where mathematical, deep learning-based recommendation engines become very important, because if you think about Netflix, for instance, went into every country very quickly. If you had to understand all of your content very deeply and your user base very deeply, it's very hard to create a recommendation engine that doesn't take a lot of work to enter a new market. So scale becomes another problem. So personalize. Very similar to what we showed you with forecast, but there is one key component that is additional that's very interesting for the real-time use case. So your data sets in Personalize are your items. You have additional data such as demographic data of your user and metadata about your items. That goes into the same type of system which extracts features and creates a personalized recommendation API. And let's go into, and this actually very similar to what you'll see with forecast, but you have these data sets. This is an example of the item metadata, or it's the user metadata. These are the built-in ones. You can add different categories as relevant to your use case. You have the required fields and then items. So you have interactions, items, and users. This interactions is a very important use case, and I'll show a demo in a little bit of why. Interactions is the ability to take that real-time data that they're utilizing. So I'm going to use just a media streaming site as an example. As you're browsing a media streaming site, you're clicking on content, you're watching content. That's what we would call interactions. A clickstream is a great example of an interaction. But it could be clicking on an email. It depends on how you define interactions. But this is real-time data that's going into the personalized API. So here, this is the user data. So you need at least user ID. But if you notice here, we have additional data like age, gender. You could add a lot of different user metadata. And then you have your items, which also could include metadata like genre, category, brand, color, any of that type of information. So much like what you saw with forecast, although you have this additional real-time activity data. So you have your inventory. Demographics is optional, but it actually helps a lot if you're building a cold start solution. So if you need something where what do you recommend? If you do have demographics on your users, you can actually get information to recommend at least something. You will be recommending popular items most likely, but you can also recommend popular items for someone of that age group in that demographic, that type of thing. So similarly, it will inspect the data, identify the features. It will select the algorithms. We do have hyperparameter, or we do have AutoML is included here. I don't have a slide, so I'm just going to talk about why you may not use AutoML. There are, trying to think the total number of recipes. Inside of personalized, there is an HRNN, which is a hierarchical recurrent neural network, which is a deep learning model that actually learns from interaction-based data and creates a deep learning-based recommendation. That's one of the use cases. There's another one which is called item-to-item similarities, which is actually based on a paper that Amazon.com published in the early 2000s, which is an item-to-item collaborative filtering solution. The benefit there is if you like this item, then you will like this item. So it is using collaborative filtering, which is a methodology to create a recommendation based on all of the different interactions all of the other users have. So if you and another user clicked on very similar items, collaborative filtering would allow you to surface recommendations based on that. What I'm getting at here is, though, an HRNN recommendation will give you the top 25 titles, whereas item-to-item similarities gives you, if you like this item, then you'll like this item. The third methodology inside of personalized is personal re-ranking, which is if you have a set of search results, you can re-rank those search results. Those three recipes are very different. AutoML would not really buy you a lot, because if you want top 10 recommendations, HRNN right now is the one to go. However, with that said, we are evolving all the time. It is very possible we will move and add another top-end recommendation model. Anything could be anything using autoencoders or who knows. Again, I'm not speaking to the future product development. I'm saying the recommendation engine space moves very fast. When it comes to neural networks, there's actually many different ways to implement recommendation engines using neural networks, HRNN being one that we find extremely accurate and extremely helpful. But AutoML, once we have multiple different top-end recommendations, top 10, top 25 recommendations, AutoML will become a lot more important. For now, and I'll show you in the console, if you want a similarity-based model, if you like this, then go with this. You don't need AutoML to tell you that. It will save a little bit of money to not run it through all the different options. So one nice thing about both forecast and personalized is these recipes have a lot of documentation that explain exactly where you might use them. Unfortunately, we don't have enough time in this session to go through all of the different recipes, but I will pull up not only the console, but I'll pull up the different ones in detail in a second. So to recap, the goal of personalized is to deliver high quality recommendations, to do it in real time, To be easy to use. Building recommendation engines is a very hard thing. And building deep learning-based recommendation engines is very hard. It is designed, much like forecast, to work across many different items. What we call an item could be something very specific to your business. It doesn't have to be a product. The features with the HRNN model is it does respond to changes in intent. It does include deep learning, and you can actually bring integrate with SageMaker to actually build these models. So I'll talk a little bit about the sequential modeling and why it's important. And this is, again, there's also a paper. I don't think we have the link here, but we released a paper in 2018 on HRNN, or the recipe that essentially became Amazon personalized HRNN model. And it talks about how the evolution of historical interest and disinterest is very indicative of what someone wants. So if I'm looking for watches in the morning, and then I switch gears and I start to look for shoes, a recommendation engine will be better suited to recommend a shoe. Similarly, if I look for shoes and then I look for watches, it seems pretty obvious, but from my experience on the web, after I search for something, I see recommendations for that for the next several days, regardless of what my intent has changed to. So the more you can accurately match what someone is looking for, the more likely that they will click on the recommended item. Recommendations also coming from a video perspective, it's not just the titles you see on a video service that are recommended. Anything from the artwork you see could be recommended. If you notice in the different platforms, a lot of different thumbnails. You might see the thumbnails change, or depending on the user, the thumbnail might change. Artwork recommendation is a very key component. Even the order of the items you see in a streaming service or even on a website could be a recommendation. So if you don't like dramas, why have drama always be the first thing everybody sees? So recommendation and personalization of layouts is very, very important. This service is designed to create an API or create multiple APIs that can create multiple different types of recommendations. So the built-in recipes at the moment are HRNN, which is the vanilla hierarchical recurrent neural network model, an HRNN model that actually takes into account item metadata, so genre, item, color, that type of thing. A third one that's actually specifically geared towards to solve the cold start problem, which is the problem when you have new users or new content constantly being added to your library. Popularity baseline is exactly what it says, which is a very common but still effective, similar to what you saw with forecast. We've included a lot of ones that aren't deep learning based that are also very important. So popularity baseline is really just showing the most popular items. But you might have a top, what's popular this month section on your website. Popularity baseline would be a great use case. Search personalization, which is where you can actually get in the process of a search results delivery, where you can say, here's the search results that I'm about to deliver, and it can rank those search results for a user. As your search results get larger, you want to surface the ones that are relevant to the person as much as possible. And SIMS, which is the item-to-item similarity, that is one that actually says if you like this item, then you'll like this item. So this is where AutoML may actually help you choose between these three, but it would be very odd for AutoML to help you choose between these 6. So you could specifically state the one you're looking for, if you're looking for SIMS, for instance. I'm going to walk through how a campaign is built and show a quick demo. But the end result is the launching a campaign will deploy all of the infrastructure needed to create an endpoint, which is then a simple API, which is either get recommendations or rank. And that is an API where you can just say, here's the current data, the user number, for instance, and then send a list of recommendations. So I will walk through it in a second. Here's a high-level view of what happens. From a browser, you're sending your real-time event data. This could be from a device, could be your mobile device. It's whatever is interacting with your service. Again, this could be a website, could be an app. That can send real-time event data in. So as you're clicking on things, this can also be pulled off of a server as well. If you've got a server running, you can actually have it pull the results directly off the server and feed them into personalize. This is just one pattern. You actually make a request for recommendation. It asks for a set of recommendations. So based on what the current set of real-time data is, you'll see the personalization or recommendations change, which then it feeds back the recommendations to your web server. Your web server then visualizes those results. I have a very simple demo to show you on it and feeds those back. A couple use cases. Domino's is using this to personalize across their customer base. Excuse me. Let me do a demo real quick. I did mention we would talk about these GitHub samples. So here is the forecast samples. I'm going to do a quick personalized demo, and then we're going to bring Chris up to do a forecast demo. I built this demo using these samples. Let me see. Any questions, actually, why I get the demo going? Yes. The data has to be in a CSV. There's an Avro schema that actually outlines what the item shape, what items you have, what the schema for your data set is. And then the data set has to be in a CSV. Although we see a lot of people using something like Glue or Spark or something to actually pull it from a source and get it into a format for training. Yes, depending on what you're trying to, the question is, can you integrate social media, for instance? It depends on what you're trying to extract, but yes, you could absolutely get insights from social media analysis and create additional data. And this is for recommendations, not for forecasting, I'm assuming, correct? For forecasting? So yeah, that additional data set, the additional data could be in many different forms. Social media buzz conceivably could be one, but it would have to be formatted into a way that forecast could use. Let me get to the demo real quick. All right, so here is I'm just running this in SageMaker. I'll show really quickly. So let me walk through the getting started in forecast and personalize and forecast. These are small little workshops that will help you building your first campaign, which in personalize is a recommendation engine, and in forecast it is a demand forecasting methodology. So I'll just quickly go through this just to show what it's doing. This also covers a little bit of the data information. So you're actually just bringing in a couple of things. So a lot of the data prep we're doing, we are using NumPy. You're essentially stating a bucket, and I'm using the Movie Lens data set. Is anyone here familiar with the Movie Lens data set? So yeah, Movie Lens is from Group Lens. I'm not using the 20 million, I'm using the 100K just for time. But I have built a model of this using the 20 million. It's the Movie Lens 20 million is, well, the 100K, which is what I'm using, is 1,600 movies over 900 users with about 100,000 ratings. And that's being used to build this recommendation system. So what I have here is actually a couple campaigns that I've built. One using the HRNN metadata, one using a personalized re-ranking, and one doing item-to-item similarities. I can show you in personalize in the console what that looks like. So you have data sets, which is, as I talked about earlier, you actually have user item event, and then interactions. The event interactions is historical interactions, and the user item interactions is the real-time ingestion of interactions. The users is my user data set, and the items is all of the items in my catalog. In this case, it's the 900 movies in the, or 900 or 1600 movies in the Movie Lens data set. So I then created an event tracker, which is the real-time data ingestion methodology. So this is actually what's bringing my clicks in. And I built these two. Looks like I only added one into the campaign, but you can, to give you an idea, and this is what I talked about earlier with forecast, which is once you have your data in here into a single format, you've already done the data prep work. So you don't need to do it again for another model. So I'm going to say I want to do a cold start one. One nice thing on top of that is you can also tune the hyperparameters or use auto HPO or auto hyperparameter optimization to actually find what is the best value. So this will constantly retrain, changing these hyperparameters, and it does use some of the SageMaker methodology, so Bayesian, to actually change the hyperparameters. And it will then train a model. Let's see. Finish. So I am now building a cold start model based on that same set of data. If I did AutoML, it would have actually done all of the different models and given me the results. Let me go back here, and in the console, you can go into the campaign and generate recommendations. I'm going to show you a nicer view of this same set of data, just because. So what I have here is this is actually a really simple Django app that we wrote that I'm going to grab a new user because I think it missed some posters. All right, so this user, which is user 291 in the Movie Lens data set, seems to really like Bruce Willis specifically. This is the ratings they've done. So this is the data this is not a recommendation. This is what they've explicitly said that they like. And in recommendation engines, the world is moving further to implicit feedback versus explicit feedback. The Movie Lens is primarily explicit feedback. By that I mean people stated what they thought of a movie. This is where many streaming providers are moving away from a rating system, and just by fact that you clicked the movie and you watched all the way through it, that is implicit feedback that you liked it. It's not actual feedback that you liked it, but it's implicitly that you liked it. You could actually combine implicit and explicit feedback. Explicit would be, give me a rating, and that way you know. Biggest problem with explicit feedback is how many people here rate every movie they watch on Netflix or on Prime Video, for instance? How many rate any movie they watch? That's the problem with explicit feedback. It's great and it's accurate, but it's usually 0.1, 0.5% of a library. Whereas implicit feedback is mandatory when interacting with content. If you want to watch something, you have to click on it. And if you don't like it, you click out of it. These are mandatory participation type things. So let's go through and take this user, and I'll show you what's happening on the back end. I'm going to just hit the API, get a set of recommendations. When did I get that right? Let me see. Oh, so let's set let me get the set of recommendations. So this is based on their reviewing. This is what the HRNN model thinks would be good recommendations based on all of their different likes over the time. I'm going to actually interact now. Oops. I'm going to go ahead and interact with this data set now. So now that I'm in the system, you see here, these are my recommendations. They actually come back looking more like this. This is the JSON response you get from Personalize. It's item IDs. I've turned them into plain text words. I'm going to start a session. So in SDK terms, I'm actually now interacting with the website. I'm now going to click on a horror movie. So I've sent a single click in. So as we talk about, the intent is important. So based on this one click, these recommendations down at the bottom should change. Let me actually just do a... So if you look, a little bit changing, adding the crow, interview the vampire, it's getting a little different. I'm now going to go off and click on a lot of horror movies. So here I'm going to separate by a second, clicking on Cemetery Man, Hellraiser, Alien Resurrection, a lot of horror movies. So now these events are being ingested into Personalize in real time. So now that those have clicked, we can go back. This should go pretty heavy horror bend. So as you can see, I'm now interested in horror movies. Now I'm going to change my intent. I'm actually going to switch and go down a comedy bend. So now these click streams are sending in real time. Now clicking on Liar Liar, Ace Ventura, Biodome. Again, the Movie Lens 100K ends in about 2000. So apologize for the dated nature of these movies. Movie Lens itself has kept going. The Movie Lens 20 million is great. It just, I didn't want to grab 20 million movie posters. So what you see here is you see some horror movie, but it's actually gone with me on the change into comedy, even a horror comedy. So this is the benefit of an HRNN model. It's following my intent as I change over time. So with that, I think we're going to bring Chris up for a quick run through the forecast, which a lot of this is actually more about the APIs than the visual. So I think we're going to be in a notebook for a little bit longer. But one thing I would say before is these are the way to get started. Personalized samples and forecast samples walks you through building everything shy of the GUI that I just showed you. Although there's that's up on GitHub as well. So if you find me on LinkedIn, I can send you the GitHub of the graphical interface that I just showed you. Cool. Chris?
Hello, hello. All right. Okay, can you see this okay? Can you guys hear me okay? All right. Yes, as Leah mentioned, there's some really, really good documentation, and I'm just going to sort of highlight. So forecast looks like it was GA in August of 2019, so 3 or 4 months ago. There's this concept when you're dealing with forecasts, you have to like provide data in a certain format, right? This is time series data, so there has to be some sort of timestamp for the first column. The second column is a value. The third column has to be the item that is tied to that value. So I'll show you guys this here in a sec. This is actually the data set that I'll be showing in the Jupyter Notebooks. I'm basically just going to do all 6 or 7 of those tabs up above there for the next about 5-10 minutes here. So this is the average power consumption per hour, and this came from the UCI machine learning repo for data sets. So it's a CSV, pretty basic stuff here. So the value, so this is the average power consumption, and this is the electricity power. For this particular client, of course, this is masked, and this is the hour. Now, one thing you probably are wondering is, well, maybe I don't collect my data at these regular intervals, right? And so forecast can actually aggregate for you. So just give it the raw data, and then forecast will actually aggregate on those particular intervals. And for the most part, you'll probably just kind of pointing to your data sets that are in S3 through the forecast console. But I will show the Jupyter Notebooks here in a sec, so you could do it programmatically. But really, all the Jupyter Notebooks are doing is just calling the forecast API to point to the S3 buckets. Okay. And let's see. Also, there's a way to define your own schema. This is pretty much the default here. There's a timestamp, there's a value, and then there's that particular item that has that value at that time. All right. So this is from the blog post, pretty detailed blog post, pretty good info. I want to point out, so Yeah, so Liam actually mentioned those 3 different types of data sets. So I'll probably skip, let's see, there was one other part. Oh, when you're dealing with like time series data, and whenever you're dealing with machine learning, you have some sort of like training data set and then a separate sort of validation data set. There's also a third test data set, but just splitting into train and test, for example, what you can't do is just disregard time. So you can't just kind of randomly choose your values, right? This is time series data, so the way that you present the data to the model, right, like during training, yes, that has to be preserved. So there's something called backtest window here. You can like define it and say 24 hours is my backtest window, and then forecast can actually split it and then maintain the order. Okay, and then one thing you should always do also is make sure that the test like data set is the same width or the same time period. If not, then right, like you'll be like basically comparing apples to like oranges. Okay. Also, forecast supports AutoML and supports hyperparameter optimization. I believe this blog post, because it came out before reInvent, probably doesn't mention AutoML because AutoML came out at reInvent this year. But just know that both are supported.
Autopilot and AutoML are different. So these have always used the term AutoML.
Oh, this
AutoML
is
an unfortunate industry term at this point.
Gotcha. Okay. But yeah, we'll see it here. So how does the forecast AutoML differ from real AutoML or the autopilot?
It's essentially running it. It's similar to autopilot as well, where it's running it through multiple different things
and then choosing the
best one based on the results. The concept of AutoML, I guess, holds true across everything.
Gotcha.
The difference is that in SageMaker Autopilot, it's really whatever linear classification or regression model that you want, whereas this is very specific to just for.
I see. I see. Okay. Okay, and then yeah, for the stream. So there's so I'll show auto. Yeah, so there's right, like this term AutoML, which is auto machine learning, right? Like automatic machine learning. It's basically the next level hyperparameter optimization, where you're not just tuning the hyperparameters for one single model, but you're actually crossing, right, like many different models. And SageMaker released AutoML at like reInvent, which was my confusion, because I come from the SageMaker world, whereas Forecast actually has had this in there. And so that's the like conversation that we were discussing. Forecast sticks to specifically time series models when it's trying to choose across models for its AutoML. Whereas SageMaker can actually cross many different models, right? Can do deep learning models, can do linear classifiers, can try all kinds of different things. Okay. Concept of P10, P50, P90 forecasts. This all ties back to the central limit theorem, you know, sort of normal distributions. So typically stick with P50, P10, P90, right, like depending on your specific use case. But yeah, P50 should be good to go. All right, so here's the console. One concept you'll see forecast holds to here. Oh, I do this with my, oh no, how do I get out of this? I somehow like maximized my screen here. All right, yeah, I'll try to. So something forecast, right, like talks about here is these data set groups. So yeah, as Liam mentioned, there's these different data sets. There's, yeah, so like Liam, what are they called again? There's the training data sets, the, yeah, the like item metadata, and there was one other one. And so you could actually group these into like what's called data set groups. And so that's a slightly different concept that's specific to forecast. Yeah, does, okay, yeah, so historical, and then the actual training, and then the item. Yep. Yeah, item metadata.
Click in there, you should see it. If you click in the data suite, you should see the different data sets.
Data sets.
There you go.
Gotcha. Yeah, question.
So when you were saying like grouping the data, grouping on the basis of what?
Right, so these are the 3 types. And the only one that's required is target. And so target is the data set that has the actual target value that you're training this model with, right? You could also provide extra.
Item metadata here could be colors, brands, related time series could be promotions, holidays. That the related time series data is additional time series data that isn't what you're forecasting, but it's relevant to the forecast. Is the use case. And then the most common one I hear is promotions, like Black Friday. Very important to a time series recommendation or time series forecast.
Yeah. So the summary there is there's 3 different types of data sets, and you can group them under one. The only one that's required is target time series, because that actually has that target value. Certain algorithms, I think Deep AR actually can support the related time series or maybe item. Yeah, just depending on the type of algorithm. But the bare minimum is that target time series. We can click in here too, look at predictors. So I actually did this through the notebooks, which I'm kind of starting with what was created, and then I'll back into the notebooks that created it. Forecasts here, so you could actually, batch produce these forecasts and save them out to S3 buckets. Let's see, forecast lookup. This I could actually do from the console what I'm going to do in the notebook, which is basically going to call into this forecast model and then provide the prediction. Okay, so let me go to the notebooks. So this is the same GitHub repo, that like Liam mentioned in his talk, and there's also the like personalized dash samples as well too. And these are linked from the blog post, from the documentation, actually from the forecast console as well too, which I thought was kind of clever. I could click on here and actually get to the samples. That same GitHub repo, somewhere buried in here. So let's just show this real quick. There's 3 notebooks that I'll cover right now. These are under the notebooks. Here's all the instructions. You could actually launch a CloudFormation like template right from here. And this is how I got this running last night. I just clicked on this. I was keeping my fingers crossed, hoping this was up to date. And it was. Just make sure that you're actually logged into your account, that you're logged into the right region, or else weird things happen. You actually create it in some other region, and then you forget about it, and then you get a bill for something big. So don't do that. And this was created by one of our SAs, Chris King, and this is actually in the repo, so I'm just going to skim through here. This is the CloudFormation template itself. You could actually go in here. I went in here, and I think I changed the instance type, or I changed something here that was specific to what I was doing. Here's a bit more on data sets here. So this is more on like the related time series and some of that stuff if you want to look this up yourself. These are the APIs that we'll be calling, which is create dataset group. Let's see. This is the data. Oh, I think I actually have the spreadsheet. This is the actual data set here. So here's timestamp, here's the value. That's the item. If we drill into the notebooks, we'll see, I'm just going to show the first 3. 4 and 5 actually go into some of the details with Deep AR and then AutoML as well. So you could see it rightly trying to choose which particular algorithm to use. 6 and 7 are just more details and different types of things like the item metadata data set. So let's just get right into 1 here. Oops. Okay, so the gist here is we're pulling in this CSV. Yeah, I've already pre-run this, so we don't have to wait for anything here. I'll just show you guys. Here we're creating that data set group based on that CSV that I loaded in. That then gets registered. I showed you guys the forecast console. That data set group got registered. Here we're defining the schema. That's pretty standard. Let me skip through here. Setting up roles and all the fun security stuff, IAM role. Okay, and once, oh yeah, actually, yeah, so Liam, I was going to ask you about the import job. Do you have much to say about that?
Yeah,
Do
so
you-
the import job is actually how, once you create the data set, that's like a holding location.
Okay.
And then the import actually is what brings the data into the
So they're separate, okay.
that was in the personalized, that's where I was able to train multiple different models because the data set was populated.
Gotcha.
Yeah.
Okay. So the summary there is that there's this separate concept of the data set itself, these data set groups, and then the actual job that's going to scrape and then pull that data in. Okay. Let's see how much time we got. A couple more minutes.
No, we ended at 2 officially. There's a break.
Oh. Oh, gotcha. Okay. So I'm in the break time here. Here's the predictor. If you notice, I'm saying don't do so don't do the auto ML, don't do hyperparameter optimization. We're just keeping it simple here. Got to back out here. Backtest offset window. The number of windows for that backtesting. And then here's the actual accuracy metrics. Root mean squared error, 8.25. This is where we create the actual forecast. Once that gets created, it took about 15 minutes, I think. Yeah, question. You could do it either way. Yeah, I did it. Yeah, yes, I did it last night and then this morning. Yeah.
Yeah, this is what's in the GitHub before getting started. You can either use the console. You find many people who are doing machine learning like Jupyter. So while you're not actually training the model in Jupyter, you're using it to actually load, prep, process your data. Many people have modified this for their use cases. Yeah, so the code's up in GitHub under forecast samples, and then it's pulling down a very generic public data set, the power one that you mentioned. You could replace that. Like I actually took for personalized, I took the 100K and replaced it with the group, the movie lens 20 million. It actually didn't take that much longer to load the data. It's really spinning up the resources to do some ETL. That's what happened when you feed it the data. It's actually processing it a little bit, getting it into a correct format.
So here's a call to that forecast model, query forecast. I'm doing pretty prints with JSON here, and then printing out P10. It should have the P50, P90 values here. So this was for a given client, and then a date, and then timestamp range here, and then showing the actual values. What was that? Sorry? Yeah, so so Google, right, the central limit theorem, and so P50 has the highest probability. It's kind of counterintuitive, like you would think P90. Yeah, right, like Liam, could you explain P10, P50, P90? Yeah, think of like the normal distribution. P50 is halfway, that's, yeah. So P50 is, was it 50% of all
50% of estimates
exceed the P50, yeah.
P90 is 90% exceed the estimate. Doesn't mean that's a 90% chance of being accurate.
Correct, right.
It just means that 90% of the estimates exceed the threshold.
Okay, and just to end on some fun, pretty charts here. All right, so we're actually passing in a validation data set. So this is basically doing batch forecast predictions. Here's just an example. So for this client, timestamp, we're actually going to strip off the value because that's what we're predicting. All right, and then this is a plot. So we could see, let's see, how did this go here? For this client, okay, yeah, wait, how did this go? Plotting the actual results. Oh, okay, yeah, so these were the actual results here. So yeah, for this forecast, so this is the actual prediction for that particular client for that range. Okay, here's another prediction. This is the P10 plot. We could do the same for the P50, P90s as well. And then we put them all together here. So there's timestamp, there's the value, and then, yeah, pretty much stick to the green there.